In this video, I'm going to talk about angle pairs. I'm going to talk about all the different types of pairs of angles that we can come up with. And there's a lot of them. We got complementary, we got supplementary, we've got adjacent, we've got linear pairs, we've even got what's called vertical angles. Up first, we're going to talk about complementary and supplementary angles. Two angles are complementary angles if the sum, that is the addition, if the sum of their measures is 90 degrees. If they add up to be 90 degrees, then they're called complementary. Okay, now two angles are called supplementary if their sum adds up to be 180 degrees. Okay, so complementary is 90 and supplementary is 180. Complementary and supplementary angles can either be adjacent or non-adjacent. Okay, adjacent means that they are next to and in contact with. At least that's how I like to describe it in mathematics, that they're also in contact with each other. Okay, so in this box we got a couple examples of complementary angles. Okay, and this picture shows that they are adjacent. Okay, so they're side by side. They actually end up sharing a side right here. And of course, because we can see the box in there, we know that these two angles add up to 90 degrees. Oh, and by the way, we do have another way of how we can identify angles, which is putting small numbers into the corners. So we call that angle 1 and angle 2. Okay, as an alternative to using a lot of letters to try and indicate. Sometimes it's easier just to put some numbers in there. So 1 and 2 definitely add up to 90 degrees. All right, now 3 and 4, I'm not going to get a protractor out and measure it, but if we were to take those angles and move them until they became adjacent, they would create a right angle. They would do that. Now, the fact that they're away from each other, they're called non-adjacent, but it does not take away from the fact that they are complementary. So complementary angles are any pair of angles, has to be two. Any two angles that will add up to create 90, whether they're next to each other or away from each other. Just any numbers that add up to make, any two numbers that add up to create 90 would give you complementary. Now supplementary, pretty much the same thing's going on here, except 180. Now the cool thing about that is that 180 makes a straight line. So this is what they look like when they're adjacent. When they're put side by side, the two unique sides that each of the angles have are going to end up creating a straight line. Okay, now they can also be non-adjacent. So they can be separate from each other as long as the measurements of the angles together add up to be 180, then that would be supplementary. In example 1, we're just going to work on identifying those types of pairs of angles: complementary, supplementary, and also adjacent. All right, so complementary has to be two angles that are going to add up to be 90 degrees. Okay, one thing I can take off the table right away is the 122 degree angle here. All right, that is already beyond 90, so we don't want to use that one. Okay, the only other two we have is the 32 and the 58 degrees. And if you add those together, you are going to get 90 degrees. 32 plus 58 is 90. So our complementary angles, now over here, this angle, you can actually just call it as angle S. That's fine because there's no confusion over here. But the angle that we have down here, we're going to need to use 3 letters. Let's just go ahead and call it BAC. Now you could also call it CAB, that would have been fine. Okay, but you do need to use 3 letters here. You can't just simply call it angle A. But on that one, you can just call it S, that's fine. All right, supplementary. Two angles that add up to 180. So for that, I'm going to go ahead and look at the 122 because I need to get up to 180, so I might want to make sure that I've got this obtuse angle involved. All right, now 122, if I add it to the 32, you can even tell here in the diagram, it doesn't make a straight line. Okay, it's not going to be enough. But if I take the 122 and I add it to the 58, that is actually going to add up to give you 180. Okay, you can check the math on that. So that means we could use angle S, and the other one we'll call it DAC. Angle DAC. That work. Again, you can call it CAD, that'd be fine, but just want to make sure that we identify those. Now, neat thing about those two that we just did, A and B, the pairs that we had were both non-adjacent, right? Because I was taking this angle, which is away from the rest, and matching it up with one or the other. So those would be non-adjacent. Now, the adjacent angles that we have in the picture are going to be these two right here that share AC. So you've got angle BAC, and you've also got angle DAC. And you can write the letters in whatever order you want as long as you have your vertex in the center. All right, so here's two angles that are adjacent, but they don't add to anything special. Example 2, given that angle 1 is the complement to angle 2, and that the measure of angle 1 is 68 degrees, find the measure of angle 2. All right, so if these are complements, that means that they need to add up to 90 degrees. One of them is 68, so all we should have to do is subtract 68 from 90. So let's take a look at that. 90 minus 68 is going to give us 22 degrees. So the answer is 22 degrees. All right, given that angle 3 is the supplement to angle 4. Supplement means 180 degrees. Given that angle 3 is the supplement to angle 4 and that the measure of angle 3 is 56, what would be the measure of angle 4? So for that, we'll be subtracting 56 from 180. So take 180 minus 56, we get 124. Next, what we're going to do is look at a linear pair. Two adjacent angles are a linear pair if their uncommon sides are opposite rays. Now that's a little bit of a heavy definition there. Lots of stuff going on there. So let's see if we can just break that down for a bit. Okay, we start off with that we have to have two angles that are adjacent. That means that they are side by side and they're sharing a side, which is what we see here, angle 1 and 2. They're adjacent because of that ray that they have. Okay, then the rest of it says that they're uncommon sides. Okay, so that's the common side. These are going to be the uncommon sides, that they are opposite rays. And now that might make a little bit more sense that you've got an endpoint here that goes in that direction, this one goes this direction, completely opposite directions. But look, here's a different way that we can just sort of describe it. They're going to be adjacent angles that when they're put together, they make a straight line. Hence the name linear pair. They make a straight line. Now, if they do make a straight line, then they have a property that goes along with them. Right? When you put 1 and 2 together like this, you make that straight line. We learn that if you were to take the measures of them together, you'd get 180 degrees. So we can say that the angles in a linear pair are supplementary. You can say that they are supplementary. So a neat little property with that. Now, does that mean that that supplementary angles are always a linear pair? The answer to that would be no, because remember that supplementary angles do not have to be adjacent. But if you do have adjacent supplementary angles, that would be a linear pair. Let's take a look at example 3. What we're asked to do here is identify all the linear pairs that we have in this figure. And what you're going to notice in this diagram is that we do have all the angles numbered because it makes it a lot more convenient for answering the question versus having a lot of letters, right? Instead of having a letter at the center and a bunch of letters on all of the rays that you have to use to name the angles, we can just simply call them angle 1, 2, 3, 4, or 5. Really easy approach at that one. All right, now linear pairs, they have to be adjacent angles that are going to make a straight line. Okay, so one thing we might want to do is just look for straight lines that we have here. Let me use this paper so it stands out a little bit better. Here's a straight line that we've got right there. Okay, all of these angles together make 180. Unfortunately, you can't call that a linear pair because a pair has to be two angles. So you don't get anything from 2, 3, and 5. You don't get to use 3 of them to make a linear pair. It's great that they add up to 180, but they don't get to be called a linear pair. However, if you go to the other side of that line, you've only got one ray that breaks up, and it breaks it up into angles 1 and 4. So that means that the angle 1 and angle 4 would be a linear pair. All right, do we have any other lines that go straight through? This one does not, right? It doesn't go straight through it. You do have a couple angles here that would be adjacent, 1 and 2, but they don't make 180, so that's not a linear pair. And same thing on that side. That almost looks like they would be complements, but we're not being asked any questions about that. They are not a linear pair. So where is it? All right, so the other line that goes all the way through is right here. And again, you've got 3 angles. That doesn't cut it for a linear pair. But if you take a look at the bottom, you've got angle 4 and you've got angle 5. So we can do angle 4 and angle 5. All right, now another little observation here that's going to pop up in just a moment in the next part that we look at. These two pairs, right? 1 and 4, they have to make 180 degrees. They have to be supplementary if they're a linear pair, right? Okay, so the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. But then we also have this pair here, which is angle 4 and angle 5 together that make 180. So if angle 1 plus angle 4 equals 180 and angle 4 plus angle 5 equals 180, what could we conclude about angles 1 and 5? We can conclude that angle 1 is congruent to angle 5. And if you look real close in the picture, you might be able to tell that that angle looks like it's the same size. And that's going to lead into the last pair that we have. And that last pair is called vertical angles. Two angles are vertical angles if their sides form two pairs of opposite rays. Again, it's somewhat of a heavy definition, and I think it's a bit complicated to really dissect the picture and match it to that definition. So I'm going to describe it a little bit different. Now, this is the official definition. I want you to see it, and I want you to spend a little bit of time to look at it and see how it does make sense for what we're going to look at here. But here's another approach. You could think of vertical angles as being, oh, by the way, vertical has nothing to do with like up and down vertical. It has to do with the word vertex, because the vertical angles will be sharing a vertex. That's where it comes from. Okay, what we have in the diagram here is just two lines that are crossing. They basically make a big X. They intersect with each other and create 4 angles. Okay, the vertical angles that we have would be 3 and 6, which would be these two right there, and then you'd also have 4 and 5, which are these two. Okay, so simply put, you could describe vertical angles as when two lines intersect with each other, they would be angles that are on opposite sides. They would be the angles that are non-adjacent to each other. 3 is across from 6, they're not adjacent. 4 is across from 5, they're not adjacent. That's what vertical angles are, and I think it's important that we at least know them. I think it's a little bit more important that we know them visually than this definition that we see up here. Now, what is true about vertical angles? Well, in example 3, I posed that question here, and well, I posed a question, and we figured out that 1 was congruent to 5. Now, if you look at the picture here, there's a line that goes straight through here. There's another line that goes straight through here. So 5 and 1 are actually vertical angles with each other. They're actually congruent. Okay, vertical angles are congruent. They're congruent to each other. So example number 4 uses the same diagram that we used in example number 3. But in this case, we're looking to identify the vertical angles that we have. Now, I also just referenced the picture from example number 3 and identified that we have vertical angles at 1 and 5. So that's not really going to be a mystery here. They're at angle 1 and angle 5. Now, are there any other vertical angles that we have here? Okay, and the problem is that ray that extends right here. If we took that out, then angle 2 and 3 together, whatever angle that would be, would end up being the vertical angle with 4. But because it is split right here, we don't actually get to create another pair. Okay, so the only answer that we're going to have for example 4 is 1 and 5. Those two are vertical angles. For example number 5, we're going to finish with an algebra-based problem. We got two angles that form a linear pair. The measure of one angle is 5 times the measure of the other, and we're asked to figure out what the measure of each of those angles are. All right, a good place to begin here would be to do a quick sketch of the picture. It doesn't need to be perfect, but we do have a linear pair, which means that once we put them adjacent to each other, you should get a straight line. So I'm just going to start with that. The other ray, when it extends out, it can be in any different position, but we know that one of the angles is 5 times the measure of the other. So I'm just going to at least make sure that we have an acute angle and then we've got an obtuse. So there's a clear difference between them, but I don't actually have it all figured out and measured there. All right, so we got two angles that make a linear pair, right? One is 5 times the size of the other one, So the other thing that we need to remember here is that when you do have a linear pair, those two angles have to be supplementary. So that means that these two angles, let's just call them 1 and 2 for the moment, that angle 1 plus angle 2 has to equal 180 degrees. Now that's just to get an outline going, just to make sure that, that you can see what I'm thinking about here. All right, now we got to make sure that this all gets sort of distributed appropriately. So we're going to bring in a variable here. Okay, there's one angle that's 5 times the size of the other. So I'm going to think about the little angle first. So let's look over here. Let's go ahead and call that one x. Go ahead and call that one x. And if that one's called x, if its measure is x, and the other one is 5 times the measure of that one, you can then describe that angle as 5x. And now that I have these two expressions, both using the same variable, which is really important here, we can take those and just substitute them into this outline that I had here. So I have x plus 5x is equal to 180. Now, of course, these can group. You get 6x is equal to 180. Divide by 6. And x is 30. So that gives you one answer. One of them is 30 degrees. The other is going to be 5 times 30, or 180 take away 30, which is 150.
Wait, what?